Hey guys, welcome to a new video. Today we're going to continue on with the financial maths topic where over the last two lessons we've done superannuation followed by loans and loan repayments. So today we're going to do a part of the topic called annuities, which for those that know, it's actually part of what they call the new syllabus that was introduced 2 years ago, where annuities previously, some schools had certain questions that touched on it, but really it wasn't a thing. Now it is. So as you may know, I'm an actuary, and annuities is bread and butter for a lot of actuaries, like the concepts and the maths behind it. It gets quite hardcore in uni, but in the high school advanced syllabus is actually really, really diluted. So I'm a bit disappointed as an actuary, but you get what's given to you. So you take what's given to you. So today, what I want to do is basically introduce the concepts and then sort of show you, a lot of the questions that are asked in the past papers and in textbooks when you write annuities, it's heavily diluted to the point where it's a simple formula where you just look up a table. Yeah, I want to give you a bit of flavor to where that table comes from, just to show you if you had to do it from scratch, it's still possible. So maybe let's begin. Also, I guess before we go on, if you haven't already done so, please subscribe to the channel and give me a few likes and tell your friends, right? And it just helps with the YouTube algorithm when they when others are searching for it. So, annuities. So I guess annuities, to really appreciate what annuities is about, I'll divide this into sort of two key points. The first one is there's this concept of present value. Present, if I spelt it better. Present value versus future value. Right? That's important. So up until now, everything that we've done in sort of financial mathematics, compound interest, simple interest, this is all about saving for the future. That's future value, right? So if I put in $10 a day and the interest rate of 5% after 15 years, the amount that I get, that's future value. Superannuation is saving for the future, right? So what is this present value business? I mean, the easiest way for me to demonstrate is if I had $100 right now, right? That $100 right now, that is present value, right? If I put this in a bank, let's say at 10% or maybe 5%, right? 5% interest, the future value becomes 100 compounding at 1.05 equals $105. That's all well and good. So the concept of annuities relates to present value mainly. And so the theory is, what if we started with $105 in the future, or in 1 year's time? Right, just like the one above, then going backwards, if the interest rate was 0.05, 5%, then I would basically calculate the present value as 105. Instead of multiplying by 1 plus r, I divide by 1 plus r, right? And that gives me my $100 at the start. So that's what present value is all about. So basically, we start with the future value and I bring it back to the present, right? That's the concept in a nutshell. So what this means for our topic, right? Now, and this is really, I mean, you would have seen in the first video when I did superannuation, I love this diagram, right? So the concept of, let's say, accumulated, let's say present. Total present value versus accumulated future value. Yeah. This diagram is cool, right? I love this diagram. So please, if anything, copy it into your books or have it somewhere, right? It's a nice little depiction of what we're talking about. So it's a timeline, right? It's a timeline. I drew this last time. Yeah, it's a great way for, if there's any teachers out there, it's a great way for you to explain this to your kids because it's a good visualization thing. So if I had, time steps of 0, 1, 2, this is n minus 1, n minus 2, etc., right? That's so important. Let's take a flashback to 2 lessons ago where I put in, as part of my superannuation, $n per period, blah, blah, blah. That, the last investment was $n there, right? I know on an accumulated basis, superannuation, I basically compound this, right, all into the future, blah, 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 blah. And the last one gets 1 period of compound. This is called future value, right? So I future value all my M payments, and that gives me a total, right? If I total it out, I won't do the numbers here, just total, that gives me a total accumulated value, right? So if you had to label that, this is an accumulated future value. Right, for all intents and purposes, the key examples there is superannuation. Right? That is a classic example. Saving, putting $10 here, for 50 years, and I get some amount in the future. Total cumulative value. We've done that before. Now, when we do present value, and I love this diagram because it shows it. Right? I'm going to bring each of these M payments back into the present. So what does that mean? If I put in $n every period for the next N periods, what's that equivalent to in the present, right? So this guy's already at time 0, so I'll bring, I don't really need to bring that back. This guy comes back 1 period. This guy comes back 2 periods. This guy comes back, N minus 1 periods, right? And that gives me what I have at the start, and this is my total present value. And the classic example here is annuities, right? So it's a really good sort of link in that the first lesson that we did in this topic was superannuation. That's the green. The third topic that we're doing is annuities, right? Which is the pink, and the middle one, loans, which is sort of like a halfway house between the two. Now, you would have, if you did the algebra for this, right? We know that the algebra for this guy, if you had to do total present value, is something that also is you take the M payments, if you do the GP formulas, etc., you get 1 plus R, and then multiplied by sort of, this is the GP, right, minus R all over R, right? Something that looks like that. Yeah, that was all good. We did that in the first lesson, right? With numbers, etc. Now, the present value formula, if you had to go down the same vein, instead of compounding, but you sort of divide by 1 plus R, you would get a very similar looking formula, right? Yeah, the mathematics behind this is very similar, where it's like 1 minus 1 plus R to come in. And for those actuaries or aspiring actuaries out there, this is bread and butter, right? And this formula here, the annuities formula, this guy here, classic, right? Now, this is the key point to make. Both of those formulas are cool, but like I said, the advanced syllabus is so heavily diluted, right? So dumbed down that all they did, right? And this is key, right? This is key. So instead of making you derive these formulas, or instead of making you use these formulas to actually calculate the value, and it's not hard, right? I can do this in like 10 minutes, right? To show you all the theory in 10 minutes. What they've done to sort of dumb this down is, instead of going P equals to M, they basically replaced this big square bracket with a factor that you look up in the table, right? So they basically said, let's replace this formula as M times F for factor, right? But just to be absolutely clear, absolutely clear, they have effectively replaced this guy with a number that you just look up in a table. And when you do look it up in the table, look up in table, there are 2 variables that you have, right? There's R and N, right? So using R and N. Yeah, and I'll show you those tables. But the theory for even the accumulated value, which we did in 2 lessons ago, right? And that was a thing that we need to calculate. You can actually, there are questions now that are basically replacing this bit here, right? This whole bit, the square bracket and the 1 plus R, with a letter, with a lookup value in a table, right? So P equals, let's call this M times F again, where they are replacing, right, effectively this guy with an F, right? Because, and it's, sorry, maybe I'll just label to the same thing. And both of these, you just look up in the table. Now, what do I mean by that, right? So what that means is that instead of you calculating, using the diagonal calculator, all you really need, right, is interest rate, time period, and then you can go up in the table. And if they give you the monthly repayments, multiply the two, and you have the total present value or the accumulated future value. Now, let's have a quick look at the factors that I'm talking about. So I prepared two tables for you, right? Generally speaking, you either get one or the other, but I'll show you some past papers today where you actually sometimes you get questions with both. But you have to appreciate, these are the two common ones. Now, I have seen questions where they sort of tweak these into different tables, but the concept is the same. The P equals to N times N. Same concept. Look at this, guys. You can see in this table here, it's a two-factor table where interest rate R is on the top, time period's here, N's over here. So if you are given R and N in the diagram, triangulate and get your factor. That's like F, and you just multiply with M to get P. Piece of cake. It is so heavily diluted. Now, let's see some examples. Let me show you how easy this is, right? This is dead easy. Guys, let me write up a quick example just to really bring this to life. And then I'll do two past paper questions and we're done, right? So example. Yeah. And annuity product. Now, just to be clear, for those that aren't familiar with what an annuity product is, right? You basically pay an upfront amount. Let's say I pay $10,000 to a company, and then over the next 20 years, they give me back each year or each month a certain amount, right? So they might, let's say, for example, let's keep it simple, right? I pay $10,000. It's a 10-year product. Each year they give me 10 each over 10 years. But instead of giving, if I pay $10,000, instead of giving me $1,000 back, they actually give me something higher to reflect interest. So I pay $10,000, they might give me back $1,200 every year for 10 years, right? So it feels like I'm making more, quite a lot of money, but it's because of the interest element. So that's what an annuity product is. An annuity product provided equal annual payments over a 12-year, yes, 12 years, man, that's a time period where interest, spell interest better, interest is earned at 5% per annum. Yeah, hey guys, there's N, there's R, right? So I can actually find the factor with those two elements. So what else they tell me? If the upfront initial cost of the annuity was $75,000, find the value of the annual payments. Cool. Now, so get this right. I pay them $75,000. Over a 12-year period, they will give me equal annual payments. Yeah, interest at 5%. So let's be clear, right? That is N. That's a weird pencil. Let's be clear. That is N, right? Let's be clear. That is R. That's enough for me to find my factor. This is my upfront payment. So using the formula, P equals to M times F, right? I already have P, right? That is 75,000. Let's go find my F, where in this case, R is 5% and N is 12. So let's head up the table. Now, this is a present value product, right? Not a superannuation savings. So future value, present value. First, maybe first thing you should identify to yourself is present value. So we're going to be using this table and not the future value, right? So is it 5%? 12 years, that's the value there, right? 8.8633. So the factor there is 8.8633. And guys, like it can't get any easier than this, right? 75,000 equals M times 8.8633. Therefore, make M the subject, throw the 8.8633 below the 75,000 on your calculators. What a joke, right? How massively diluted of a concept is that? Yeah. I mean, it breaks my heart as an actuary that they haven't actually asked you to calculate all stuff, but you do what's given to you, right? That's the question. Let's do 2 past paper questions really to prove, for me to prove to you that this is actually as easy as it gets, right? Oh, sorry, not as easy. This is the textbook concept, right? Obviously, there are questions that can be harder than this, but yeah, this is the meat of it, right? Let's look at this, right? This is from CSSA, 3 marks in this year's CSSA paper. Emma is saving up for a new car. She deposits $2,200 into an annuity account, right? At the end of every year for 4 years. So that looks like a monthly amount, right? Looks like a monthly amount. The account pays 3%. So that is R, right, actually 4 years. That's it. The table shows the future values of 1. So this is a saving element, right? Now, I think there is a misconception in the way that maybe as an actuary trained in what I do, the word annuity usually refers to present value. But in the advanced syllabus, annuity just means either future or present. So in this case, we're talking future, right? Because she's saving for a car for the future. Yeah? So she's putting in, so this is like a superannuation question, right? Just be clear, because it tells you that this is a future value table. So, all right, let's do this. How much interest? Ooh, right? So just be clear, right? What I'm finding at the end here is the total accumulated value with interest. So, using the terms of principal plus interest equals total amount, I'm finding the total amount. Okay? Just keep that in mind. So I'll show you what I mean. Guys, let's use the formula. Let's do this, right? It's 3 marks. Watch how easy this is. So in this formula, what's been given? I know my monthly amount is 2,200. I know to find the F, I need 2 variables. N is 4, R is 3%. Guys, where is it? Let's look it up. So let's see, 3%, 4 years. So this guy here is the factor that I want. So the factor is 4.1836. Yeah, that's it. So therefore, my total amount, right? The total amount that Emma gets at the end is 2200 times 4.1836. I believe if you punch that successfully into your calculator, 9,203.92. You guys satisfy yourselves that's perfect, please. Because once you do that, now we're almost there. I reckon that's probably like, I don't know, 1 or 2 marks, right? I want to find the interest. That's the total amount, right? So she's put in 4 lots of 2,200. So her principal, so now her investment is 4 lots of 2,200s. So then the difference is interest, right? That's exactly what they want you to find. So this is what, 8800. And guys, if you take the difference, right, therefore interest, subtract out, what do you get? Is that like 400 something? 03.92. Done. 3 marks. CSSA this year's advanced paper. Yeah, what do you reckon? Right? That simple formula to kickstart everything, that is key, right? That is absolutely key. It's not hard. Once you sort of practice this enough, you'll see that it all boils down to that P equals to MF, right? P equals MF. With F, they give you two variables for you to find it on the table. So another one. Yeah, do another one. This is a Sydney grammar. Funny enough, that's 3 marks here. I think these 3 marks are more reflective of the previous 3 marks. Now, I like this question. This question has both. A bank has provided 2 brief annuity tables. Now, future value and present value, right? Depending on what she wants to do, right? What Jocelyn here in this question wants to do. And the interest rates are 1, 2, 3, 5, and again, same period. Cool. So let's see. Jocelyn pays 5,000 per annum into a superannuation scheme. Sounds like she's saving here, right? She's saving here. So that is M. Super, right? Sounds like future value. 4%, right? 4% now. What is her total value after 20 years? And that's the last piece of the puzzle, right? That is N, right? So this is, we're going to use the future value first, right? And then I suspect that's this question. I don't even think we use the present value. I think it's just there to confuse you or to mislead you. Guys, for part A, once again, P equals to MF, right? Yeah, so I got P. No, I don't have P. That's what I'm finding total value. Got M. And let's find in the future value table. N is 4%, so 4%. N is 20 years. Feels like it's that guy, right? Feels like that guy. So 29.7781. If you have successfully punched that into your calculator, 4, what's that? 8891. Done. 1 mark. Yeah, not bad. Hubby. Sammy, someone else, wins the lottery and invests all 80,000 at 4% for 20 years. Okay, that's just simple compound, right? So that guy there is just simple compound. Yeah, invested for 20 years, perfect. How much would Jocelyn need to increase her annual repayments by to match? Okay, cool. So firstly, let's work out how much Sammy has at the end of 20 years. We compare it to that and then see how much extra we need to do, right? Yeah, or we can compare it to the 5,000. Either way, let's see. So I've got, so for Sammy, color. Sammy looks like he's got 800,000, sorry, 80,000 rather. Let's just compound this. 1.04 to carry 20, right? That's what he's doing. $8,000 compounded 4% times that. So if you punch it into the calculator, quickly do that. 20. Yep, so 17 something, is it? All right, looks low. Not right. 17,528. So what you guys got? Yeah. Now, that is at the end of 20 years, right? No, that's wrong. That's clearly wrong. 80,000. Clearly, right? I'm like, how does that compare to this? Let's get rid of this. Perfect. Times my answer by 10. 289. That's better. Yeah. Now that is clearly higher than that. So the question is, how much more, right? Do what it is. So all I'm going to do, right? Let's see if this makes sense. All I'm going to do, because I know this guy, right? If I divide by the same 29.7781 factor, right? Because this is almost like Sammy's P value, right? Yeah. And I know that P equals to M times F, and the F factor is the same, right? Yes, F factor is the same because it's 20 years, 4%. So I'm just trying to find what Sammy's equivalent M value is. I'm just going to divide it over. Does that make sense? So once I do that, let's see what we get. right? So this should be a bit above the 5,000 that Jocelyn put in, right? So if I go back, divide by 29.7781, yes, it is. So it's 5886.5. Now, percent US dollar. US dollar. Just get rid of that. 57. Right. So it looks like it's $887 more. So therefore, $887 more. That's what she needs. Does that make sense? Yeah. So basically, we got a new total at the end, a new p-value. Divide by the same factor, same interest, same 20 years to get the new monthly repayment or periodic repayment, and then get the answer, guys. So hopefully this lesson gave you a bit of insight into the way annuities are done, mainly through tables. You can do it from scratch using the formulas that I gave you at the start. You can derive those formulas quite simply based on sum of the GP. So if you like that video and it was useful, please give me a like, hit the subscribe button so that others can find it, please, and tell your friends. Otherwise, I'll see you later.